So if you remember previously, what we did was we took equations like y equals negative x plus 2. We filled out the table for them, so I gave you some numbers to use for x, usually like negative 1, 0, 1, and 2 will work. And then you replace those numbers in for x to get your y number, and then you get ordered pairs. You plot those ordered pairs, you make a line, and then that would be the graph of that linear equation. Today I'm going to show you how to solve and graph linear equations using a specific formula without making a table. So a line written in the form y equals mx plus b can be graphed without actually making a table of points like we did last time. This is the standard formula for slope-intercept form. So it starts with y equals, and this number here, it is considered the slope. So they use m as the variable showing slope instead of s, but you have to just understand that m is representing the slope in the formula. And b, they use another random letter of the alphabet. B is the y-intercept. This is considered slope-intercept form. So on our last video from our last section, I quickly went over the 3 different forms, and this is the first form we're learning. Slope-intercept form gives you 2 things. It gives you the slope and it gives you the y-intercept, hence the name slope-intercept form. So the number that's in front of x here is going to be the slope. That means the steepness of the line. And the number on the end here, whether it's positive or negative, that's where it's going to cross the y-axis. So for example, we have an equation here, y equals 3x minus 5, and it's asking us to graph this. Previously, we would make a table, we would pick some x values, replace those numbers in for y, and then we would get ordered pairs, and then we would graph those ordered pairs. Now, I can tell what the slope is and what the y-intercept is by looking at the equation. The y-intercept is going to be the number on the end. So the y-intercept in the formula, we could see here, it's the second number here, so it's the b value. Since this is a negative 5, a minus 5, that means the y-intercept is negative 5. Also known as, if you're on the y-axis, then the points that are on the y-axis have a 0 in for x. So negative 5 on the y-axis is the same thing as the point 0, negative 5. So on the y-axis, we go down to 5, 1, 2, 3, 4, 5. We make a point. And I know that this graph has a y-intercept of negative 5, and that's where this line crosses the y-axis. I know that because the formula says for slope-intercept form, the first number that's given is the slope, the second number that's given is the y-intercept. So I kind of already did this up here, but this says this represents the point on the y-axis is at 0, negative 5. Okay, so that's what this means. So you plot that point there on the graph, and then you move on to the slope. Now you could do it in the opposite way. You could write down the slope first and then the y-intercept second, but the slope does not give you a point. The slope tells you how much to go up and how much to go over for your line here. So here's the equation, y equals 3x minus 5. We already used the minus 5. We already plotted the negative 5 on the y-axis. So the slope has to be the other number. The slope is always the number in front of x. I'm going to repeat that. The slope is always the number in front of x. So the slope in this case is 3. Now slopes, though, are steepnesses. If you're thinking of slopes, you should be thinking of like going up steps. When you're going up steps, you have to do 2 things. Not only do you have to go up, but in order to get to that next step, you have to go over as well. So slopes of whole numbers like 3, we have to understand that there is an invisible 1 underneath of it. We just don't usually write anything that's unnecessary in math. Like you would never see me write a final answer of 3 as 3 over 1 because there's no point to write the over 1 part since it's not needed. 3 divided by 1 is just 3. But anytime you have a slope like this that is a whole number, There is an invisible 1 underneath of that. Slope tells you two things. Slope tells you the rise over the run. The rise is how much you go up or down. The run is how much you go left or right. So a slope of 3, or a slope of 3 over 1, says that to get from one point to the next, you go up 3 units and you go over 1 unit. So to get from our original point, which is the y-intercept is a point on this graph here. It's at 0, -5. To get to another point, we use the slope of 3 over 1. That means we start here at our y-intercept, and since our slope is 3 over 1, that means go up 3 units and go over 1 unit from the starting point. So going up 3 means go 1, 2, 3 up, and over 1 would land you right here at this point. That point is at 1, -2. And I can keep doing this. Go up 3, 1, 2, 3, over 1, make another point. They will all lie on the same line. 1, 2, 3, and over 1. 1, 2, 3, and over 1. You only need 2 points to make a line, but using slopes, you could just keep going because the slope never changes. The slope is the constant rate of change. The slope for this line is always 3 over 1, meaning to get from one point to the next, you go up 3 to the right 1. In addition, if you wanted to get some points on the left-hand side over here, you could also do the opposite of going up 3 to the right 1. You could also go down 3, 1, 2, 3 to the left 1, and get another point that's also on this line. Now, because we're in a weird year and we're not going to be as accurate as we normally would in algebra, what you're going to be doing when you're graphing these points is drawing the best sketch that you can connect. Ooh, that was really good. I don't know what happened there. You're going to be drawing the best sketch that you can, connecting these points without a ruler. In a traditional Algebra 1 class, I would give you guys all rulers, and we would use rulers or straight edges to make a perfect straight linear line, because linear lines are perfectly straight. But because we don't have those this year, we're going to make the best sketch we possibly can. When we take our quiz on Thursday, I'm creating the questions in Schoology so that you can sketch them by hand actually in the program without having to do it on a piece of paper and then upload a picture. But you're going to have to sketch it. It's not going to be perfect, but you're going to have to try and do your best by showing me the points so that you understand what to do here. So that is how to graph an equation in slope-intercept form. Every question is going to be a little bit different though. So if I look at the next one, this one is different than the first one. I'm still going to do this one with you and not have you guys try this on your own yet. The equation that we now have looks different because I see negative numbers, I see fractions, and then automatically some of you might want to freak out like, all right, I'm not into this problem. The first one seemed easier. But it's the same exact type of question. It's asking us first for what the y-intercept is. The y-intercept in slope-intercept form is this number right here. The last number that you see is always where this crosses the y-axis. So the y-intercept is 3, which means that it crosses the y-axis at 0, 3. So the first thing you can do when you see an equation in slope-intercept form is identify the y-intercept. That's where it crosses the y-axis, and then you can take that point and you can plot it, knowing that this is one of the points on the line. So one of the points on the line is at 0, 3. That's where we will start our equation. Our equation is going to start here. And then what we will do is we will take the slope and we will use the slope to get more points on the line. Now the slope, you're probably already thinking, is this number here because the number that was not used yet, and that's correct. The slope is -1/2, and that is because the slope is always the number in front of x. The y-intercept is always the constant number at the end. So the slope of this line is -1/2. Now the way that they have it written, the negative sign is like on the same line as the fraction. Whenever you have a negative number, you can either have the negative on the outside like that, or you can have the negative in the numerator, or you can have the negative in the denominator. I personally prefer this way. I would rather the negative always just be in the numerator rather than have the negative on the outside or have the negative in the denominator. Having the negative in the denominator just doesn't look right to me. Having it on the outside is fine, but I prefer this, especially for slope. And the reason why is slope is representing the rise over the run. If you have the negative just on the outside of the fraction, you're not really sure what to do here to make it a negative slope. If you have the negative in the numerator, then it's easier to see that the rise is not going to be going up, it's going to be going down. And I can tell it's going down because of the negative 1. The negative 1 rise means moving down, not moving up. So that would be going down 1, and then a positive 2 would be moving over to the right. So this slope, negative 1 over 2, means that I would start at my y-intercept, which is 0, 3 right here, and then from here I go down 1, and I go over 2, and I make a point. I go down 1 and over 2 from there and make a point. Down 1 over 2, down 1 over 2. And if you keep doing that, you will keep creating points that are along the same exact line, because slope is a steepness that connects all of these points that are on the same line. Once you have 2 points, you only need 2, but once you have 2 points, then you can draw a sketch, a line through all of the points to the best of your ability, and that is your equation of a line in slope-intercept form. Okay, so what we are going to do now is continue graphing linear equations. All of these equations are in slope-intercept form. So let's start here with these examples. I'm going to have you guys try a couple on your own. So the directions are graph the linear equations on the coordinate planes below. Make sure to extend the line across the whole plane, meaning draw the points. You only need 2, but then you should extend it all the way through so that it covers the whole graph. So the first equation is y equals x. It's just plain y equals 1x. Now the y-intercept is always the number on the right-hand side, and the slope is always the number in front of x. Right now there is an invisible 1 in front of x, so the slope is going to be 1 since there is an invisible 1 there. But then there's no number on the end, so because there's no number being added or subtracted, we can conclude that the y-intercept is 0, which means that this graph starts at the origin at 0, 0 right here. So it crosses the y-axis at 0 because there's no number there. And the slope is 1. That means that the slope, since slope is a 2-step process, since the slope is 1, the slope is really 1 over 1. Meaning from our y-intercept, we would go up 1 over 1. So from 0, 0, we would go up 1 over 1 and make a point, and then we already have our line. But you could just keep going. The equation y equals x is just going to be a slope of 1, so it's just going up 1 over 1 and crossing through the y-axis at 0, 0, so it would look like this. This is actually called the parent function for linear equations because this is the typical normal one that we would start with. A slope of 1 is meaning like this is the standard slope crossing through the y-intercept here at 0. This is the original function. And anytime we make the slope steeper or we make it negative or we do anything to it or we move it around, it's considered a transformation of this one. The second equation is very similar to the first one. The only thing that's different is that the slope goes from a positive 1 now to a negative 1. This equation, y equals negative x. I know there is a negative 1 here in between the negative and the x. And because there's nothing to the right of it, I can assume that the y-intercept is 0 since it's not there. And anytime, like if you're adding 0 in math, people will just get rid of that because you don't need to show it, so that's why it's not there. So this means that we would graph this by plotting the y-intercept, which is also at 0, 0 at the origin, but now my slope is a negative 1 over 1. That means that to get from one point to the next, I would go down one to the right one. So from here, I go down one to the right one, down one to the right one, down one to the right one. So this equation is going to look very similar to the first one, but instead of being a positive one slope, it's a negative one, which just looks the opposite. So it's the opposite diagonal. So your whole goal in graphing these equations is first identifying the y-intercept. The y-intercept is the second number in the equation. And then once you have the y-intercept plotted on the graph, then you use the slope to get at least one more point. And once you have 2 points on the graph, you connect those 2 points and you have your line. So what I want you to do is try problems 1 and 2 on your own. First thing is that you have to understand, and if you forget, just look back in your notes, the formula for slope-intercept form is y equals mx plus b. The number in front of x is the slope. The number here in the end is the y-intercept, which is where this graph crosses the y-axis. So the first thing you should do is identify where the graph crosses the y-axis and make a point on the y-axis where it does. And then the second thing you should do is identify the slope. Slope is always a fraction, even if it doesn't come up as a fraction. And then use your slope to get one more point. I'm going to give you a few minutes to try these on your own. I really want you to try these on your own, not just wait for me to do it, so that you can practice this and then check your answers with me when I go over them. So I'll give you a few minutes and then we'll go over them. All right, let's go over these answers. So the first one, y equals x plus 1. To graph this equation, we first have to identify the y-intercept. The y-intercept is right here. It is at positive 1 on the y-axis. So we go to 1 on the y-axis and we make a point here. The point that is the y-intercept is 0, 1. So anytime you're on the y-axis, 0 is what is in for x, and then 1 will be where you plot the point. The next thing we do is determine the slope. The slope is the number in front of x. Right now there is no number in front of x, but anytime we see just a plain x, we know that there is an invisible 1 there. So this is 1x plus 1, meaning that the slope, since it's 1, it's going to be 1 over 1. You always put a 1 underneath of any whole number because slope is a two-step process. This means to get from one point to the next, you go up 1 over 1. So from the y-intercept, which is at 0, 1, I will go up 1 and over 1 and make a point. All you need is 2 points to make a line. So you could just make your line there, but if you wanted to just keep going, so you make more points, that's fine. To make points, the left-hand side of the original point, you can go down 1 to the left 1 to make more points, and that would continue your line. You should extend your line all the way through the coordinate plane to show the whole thing. Please do not just connect the 2 points and then be done with it. You have to extend the line through the whole thing because these lines do go forever. These are continuous graphs. And then the second one, y equals negative 2x plus 4. So the plus 4 here is our y-intercept. So on the y-axis, we'll make a point at 0, 4. 1, 2, 3, 4, make a point here. And then your slope is going to be the number in front of x. In this case, the number in front of x is negative 2. We're going to put a 1 underneath of that since it's a whole number. Well, it's an integer, and we have no number underneath of it. You're going to want to put a 1 there so you know that you're going to go down 2, but you also have to go over 1. So from the original point, we're going to start here by going down 2, 1, 2, and over 1, and that will be our line. Down 2, over 1, down 2, over 1. You connect the points the best of your ability, and then there is your line. Notice when you have a positive number in front of x, your line increases from left to right, and that's because it's a positive slope. And when you have a negative number in front of x, the line decreases from left to right because it's a negative slope. All right, moving on, we have a couple more, and then we will call it a day. So we're going to finish this page here. I'm going to start number 3 with you, but the rest of these have fractions, and I'm going to start them with you so you understand what this is and that there is really no difference. It's just these ones have fractions. So looking at the next page, number 3, 4, 5, and 6 is what we're going to end with today. I'll do number 3 with you. The first thing we have to do is identify the y-intercept. The y-intercept is the plain number on the end. Because it's a minus 2, that means the y-intercept is negative 2. So you make a point at 0, negative 2, or just at negative 2 on the y-axis. That is your starting point. This slope is a little bit different. This slope starts out as a fraction. Don't be scared when you see a fraction as your slope. Slopes are always fractions. Every time we had a whole number as our slope, we've made it into a fraction by putting a 1 underneath of it. So the slope of this line is 4 over 5, meaning that instead of going like up 2 over 1, we're now going up 4 over 5 units from the starting point. Slopes are always fractions, so when you see fractions, don't get scared. All you're doing is you're starting at your y-intercept here at 0, negative 2, and then from here you go up 4 units. 1, 2, 3, 4 units, and over 5. 1, 2, 3, 4, 5, and it's going to bring you right here to that point. So if you're looking at what's happening here, please realize the slope is always the rise over the run. What we did here is we went up 4 units. So we went up 4 and we went over 5 units. So that's what the slope is showing to get from one point to the next. If you're imagining like taking a big step, you'd have to go up 4 and then over 5 to get to the next one. If you wanted to make another point, you could. You would just go up 4 from here, 1, 2, 3, 4, and over 5, 1, 2, 3, 4, 5, and you can make another point. Then you extend your line all the way through, and that would be the equation or the graph of that equation. So what I want you guys to do is practice 4, 5, and 6 quickly. We do have 9 minutes. We'll only need like a minute or two to go over them. I do just want to quickly show you that if you have a negative number on the outside of a fraction like that, I always put the negative with the numerator. So instead of writing negative 4 over 3 like that, I would put it as negative 4 over 3. It's just easier for me because if not, then you're not sure where the negative goes. When you have a negative fraction, you only need the negative somewhere, either on the outside, on the numerator, or the denominator. But I would always put it with the numerator, and then you'll know just your slope means go down, but always go to the right. So I'll give you a few minutes, probably like 6 minutes, and then at 9:08 we'll go over the answers and then call it a day.